Okay, so here's our vectors question in 2 dimensions, and you can see some i's and j's involved and nothing to worry about too much. So we just try and unpack the question a little bit. What do we have here? We've got a yacht sailing at a constant speed of 5 root 10. Let's put that aside. 5 root 10. So that's the speed. Now that would be, remember, the absolute value of velocity would be the speed, right? Because speed doesn't have a direction, velocity does have a direction. So the absolute value of velocity is equal to 5 root 10. We just put that on the side there. There's a direction that the ship seems to be heading in, this yacht, and there's a starting position. So maybe we just put some reference grid down, because that might help us understand what's going on. It tells us there's a beacon somewhere here, a beacon, and the yacht is initially at -610. Let's put the yacht here, the starting position, -6,10. And it's travelling with a direction vector -I minus 3j. So I and j are just the x and the y direction. So it's going -1 in the x and -3 in the I. So it's travelling in this direction, right? Fantastic. So we might write that as a vector equation of the line, right? So let's try and write it here. R equals the initial position, jump out on a vector from the origin, and then it'll be plus t, and in here it needs to be the velocity vector. Now all we've got at the moment is a direction vector, which is -1, -3. Now we want to just have a little look at this, because -1, -3, -1 squared plus -3 squared, all square rooted, gives us root 10. Okay, so that's not too bad. In here, if this was the velocity vector, that would give us a speed of root 10, but we know the speed has to be 5 root 10. So we need to make this 5 times bigger. So this is 5 here, and this is 15 here. Now it's important that we get the velocity vector exactly correct inside here, all right? So now we've got the actual equation of the vector equation of the line that the yacht travels in. We can pretty much answer all the questions. I mean, we could have answered some of these questions even before we put the vector equation of the line on there. But it's quite nice to have that vector equation, right? So part A, or part 1, the initial position vector of the yacht. Well, the initial position vector is where t equals 0 here. So the position vector is basically just the coordinates, but written as a vector, as a journey from the origin. So there's 1. Here's 2, the velocity vector of the yacht. Okay, so we kind of did all of that in terms of our equation of the straight line. -5, -15. It's important to get the negatives as well, because that gives us the direction of motion. And 3, the position vector of the yacht after t hours. Okay, so without even reading the question, we actually jumped straight to part 3 and did it straight away, right? But that for me is how to make sense of the question. You know, a yacht is travelling somehow. And so I just really want to get the position vector of the yacht after t hours. Okay, good. B, find the time when the yacht is closest to the beacon. So this is always a nice question, right? Because I suppose what we're doing is the distance from the beacon to the yacht is indicated by this, right? Now we know this is 0, 0 here. And we know the x and the y coordinate here. Now we're going to give the x and y coordinate in general terms. So we basically unpack this nice equation. We break it down to the x component, which is -6 minus 5t, and the y component, which is 10 minus 15t. And now these two are the general xy coordinates on the line. So we just got to transfer this over, negative 6 minus 5t. So any point on this line here, negative 6 minus 5t is the x-coordinate, and the y-coordinate 10 minus 15t, 10 minus 15t. And so basically we want to find the distance between these two coordinates. So this is just a Pythagoras distance between 2 points and a 2D coordinate situation. So we have distance is equal to the square root of y2, 10 minus 15t, minus y1. Well, obviously the y1 and the x1 are both 0, 0. So we're just going to have the y2 squared plus the x2 squared, because there's nothing to subtract. And we just have to go and find the minimum value of this. So this is where you would actually just put this directly into your TI Inspire. No need to even do any algebra expansion, right? And f1 of x would represent the distance, and you would plot all of this, right? You'd obviously just change the t into an x. And when you plot that function, you will get something looking like, you know, and then you want to find the minimum. I've already pre-done it on my TI Inspire, so I'll just write down the answer that you should get. And the answer you should get, I'm just grabbing it from my calculator now, is, when t equals 0.48 hours, and the distance is approximately 8.85 kilometers. And when we go back to the question, if there is a reef of radius 8 kilometers around the atoll, will the yacht hit the reef? And so you can kind of get the sense, right, that, you know, the 8 kilometers circle is looking like this. But of course, the ship only travels to within 8.85 kilometers, so we will miss the coral reef and be safely traveling the island. So I hope that helps. The written work at the end looks a little bit messy, but hopefully you can follow your way through step by step. I think for me, the key thing for me was I'm really trying to get out this position, right, the position of the yacht after T hours. Another thing to remember is this r at the start is just the same as the x, y position vector, all right? And that's why we could actually rip that apart and write it down as parametric equations down here. Hope that helps.